This video is a continuation of the previous video, and we're continuing to work on this database, this case that introduces databases that accountants would use. And so we've taken these four data sets, customers, orders, order details, and products, and we've manipulated them, filtered them, and then we've joined them all together, merged them all together, and we have our database where we left off in our last video. Now we can answer these questions that we were asked here. These are just 10 questions that are examples of what questions that companies might want to ask. So the first question is, who are our top 3 most profitable customers? Well, profitable, we don't have a variable here for profit. Each row in this database gives the order, it's an order ID, customer ID, product triplet. So this is the order ID 44 placed by this customer. What product did they buy? This product. Also, order ID 44, this customer, they also bought this product. So order ID 44 was a multi-product order by this customer. And the profit we don't have. We have quantity we sold of that product. We have the price we charged per unit. We know what it cost us per unit to make that product that was sold in this order. But we don't have the profit. So we really need to create 3 variables. We got to create a total revenue variable, which would be price times quantity, a total cost variable, which would be cost times quantity, and then a profit variable, which is the revenue minus the cost. We need to create that profit variable. For each row of this database, we need to find the profit. So to do that, we use a formula tool. And we're going to create 3 new columns. First, total revenue. We want all 3 columns to be numeric data type. Total revenue is going to be our price variable times our quantity variable. Price is what we charged per unit of what they ordered. Quantity is how many units they ordered. Next variable will be our total cost variable. And that is going to be equal to our standard cost variable times quantity. Make that a double variable type, numeric. And then the final variable will be profit. And that's going to be equal to our total revenue variable, which we just created up here, minus our total cost variable, which we created below it. Make that double numeric. Don't leave it a string, or else we won't be able to do any mathematical operations on profit, like finding the sum or the average by customer, by city, things like that. We won't be able to do any of that if profit is a string variable. So make sure profit is a numeric variable. We'll run this, and we have our 3 new fields, 3 new variables, 3 new columns, however you want to say it, created over here. For each row, the total revenue, total cost, and the profit should be the difference between revenue and cost. We can check $450. That should be what? 25 times 18. Order ID 44, customer 1, placed an order for Northwind Traders Chai. They bought 25 units. Now a unit might be a box of 200 bags of tea. How do we know what a unit is? Well, that was over here in our products data set. We didn't keep that variable because we don't really need it. But over here in our products data set, for each product, we had this variable right here, which told us what 1 unit was. 1 unit of Northwind Traders Chai is actually 10 boxes, and each box has 20 bags of green tea. But anyway, we don't really need that. We don't need to know that. So they bought 25 units of Northwind Traders Chai. We charged them $18 a unit. So the profit is 25 times 18. I'm sorry, the revenue 25 times 18, 450. The total cost, it cost us for each unit of Northwind Traders Chai, we cost us, well, we are Northwind Traders. For each unit of chai, it costs us $13.50 to buy it or to make it. I'm sure we're a retailer, so to buy it, and 25 of them, so the cost was $337.5 to us, so our profit $112.5. Now that we have this profit variable, now we can actually answer all of the questions here. So first one, who are our top 3 most profitable customers? To answer these questions, pretty much all of them can be answered with a summarize tool. We just attach a summarize tool to our database. We want to group by customer ID or customer name. Let's group by customer ID. And we also want to find, what are we wanting to find for each, for each customer? The total profit. So sum profit. We'll run that. Here's the output. It puts the output in order of customer ID, ascending order. So we want to filter this by profit in descending order. So our top 3 customers are customer 28, 7, and 4. Which customers are those? We would have to go map those to the customer name. Or we could have just grouped by customer name. I believe this is company BB, this is company G, and this is company D. Our worst customer is customer ID number 25. How long on average do orders take to be fulfilled? Let's go back to our database. What we want to do is we want to find the unique orders. And then once we have the unique orders, we can calculate the average of this column. Order fulfillment time in days. The reason is, if we don't find the unique orders first, then multi-product orders, like this first one, 44, there are 3 products that were ordered. That order took 9 days to fulfill. And we're going to grab all 3 of these 9s, and that's going to be included in our average, and it's going to bias the average upwards. So hopefully it makes sense to just take the unique orders and then take the average. So to do that, so I'll show you, what if we didn't take the unique and we just attach a summarize tool. We grouped by order ID, and we found the average order fulfillment time. Or no. What if we did not group by order ID? It didn't say to group by order ID. It just said, how long on average do orders take to be fulfilled? It just wants the average order fulfillment time, total. So we found the average here. It's just going to spit out one number, 3.64 days. But I don't think that's accurate because of what I said earlier. For orders where more than one product was, for multi-product orders, we're taking that order fulfillment time number and we're just repeating it, and we're including it in the average. But really, this is all one order. This order took 9 days to fulfill. We don't need to be averaging 3 9s here. So, the average of 3 9s is exactly the same as the average of 9. But if, hopefully you realize mathematically, if we took, where's the next order? 71. So these are 2 orders, 44 and 71. The average order fulfillment time should be 9 plus 1 divided by 2. But if we take all 3 of these 9s and say the average order fulfillment time is 9 plus 9 plus 9 plus 1 divided by 4, that average is going to be a lot bigger than the 9 plus 1 divided by 2. 9 plus 1 divided by 2 is 5. That's the average order fulfillment time. But 9 plus 9 plus 9 plus 1 divided by 2 would be what? 28 divided by 2? 14. So it took 14 days on average, but neither of these orders took 14 days, right? So hopefully you see we have to find the unique orders first, and then we can calculate the average. So that 3.64 that it spit out here is the average order fulfillment time in days. That's biased upwards. It's not right. So this just highlights the idea that you really have to know your data. You can't just randomly be. Alteryx is very powerful, but it's only as good as the person using it, understanding their data. You're only going to get the insight you get from your data using Alteryx is only as good as what you know about the data, in a sense, how you program Alteryx. I mean, the robot will only do what you program it to do, essentially. So get rid of that. Unique. First, find the unique order IDs. Here they are. There's no repetitions of order IDs. And then we just want to find the average of the order fulfillment time in days column. So then we can just attach a summarize tool to the unique, and we can just find the order fulfillment in days column and take the average. Run. Now instead of being 3.64, it's 2.92 days. So on average, it takes 2.92 days to fulfill an order. The customer orders on a given date. On average, it takes 2.92 days past that given date for us to ship the order to them. How many unique orders were placed by our customers? Well, we've already determined that. We can just look at this unique and we can count the number of rows here, or we can or we could just, in this summarize tool, we can add order ID to it and we could just count them. And then look at the output. Average order fulfillment time in days, 2.92. The number of unique orders, 39, because we've counted order IDs. Essentially, we just counted the number of rows in here. Because each row is a different order ID number because they're unique. 39 orders were placed. What is our profitability by month? So that's why we created that month variable back here with this formula tool. We did that in the previous video. We created that month variable. Because of this question, what is our profitability by month? We attach a summarize tool to our database, and we want to group by month, and we want to find the sum of our profit. No, not the sum. Does it say the average? What is our profitability by month? No, the sum, total. Hit run. Look at the output here. Here are the months. Now it always lists the output. The output is sorted by the first variable in ascending order. In this case, in ascending alphabetical order, because this is a character variable string. If we want to sort by the second variable, we have to click here and we can sort it. This means descending order, this means ascending order. So our top 3 months in terms of profit, March, April, June. And it looks like our database must only have order data from the first half of 2017, January through June. It doesn't have data July through December. When we get that data, we could add it and we could combine it to our current database. Suppose every 6 months, the company keeps track of their customers, orders, order details, and products in 4 data sets. And every 6 months, we have to do exactly what we're doing in this case, merge everything together and get a database. So in every 6 months, our database grows, and we can just keep attaching onto it. Just keep running this workflow and attaching on. But anyway, for the first half of 2017, sorting by month here, by profit. March was our best month. April was our second best. June was our third. May was our worst in terms of total profit. What are our top 3 most profitable products? Attach a summarize tool. We will group by either product code or product name. We'll group by product name. And we want to sum the profit for each product. Whoops, I put an extra thing in here. Let me get rid of that. Grouping by product name, summing the profit. This will give us our, for each product, the total profit. This is in, ascending order on this variable. Sort it by the profit variable in descending order. Our best product was our coffee. That was the profit we realized from selling coffee to the different customers we sold coffee to. Boysenberry spread was the second best, and then our beer was the third best in terms of profit. Worst was dried plums. Not surprising, those don't sound very good. Actually, they may be good. But they were the worst in the terms of profit. Maybe it's because we're in the first half of the year and they don't sell well. Who knows? What are our top 3 most profitable cities? Grab another summarize tool. Group by city. And then sum profit. And then again, everything is listed, the data is listed in ascending order on this variable here by default. So we want to sort it by the profit variable in descending order. So in terms of total profit, Memphis was our most profitable city, selling to customers in Memphis, then selling to customers in Boise, Idaho, and then selling to customers in New York City. Our least profitable city was Seattle. You can also sort this by attaching a sort tool, and I've shown you that in a previous video. But if you're only sorting on one variable, just sorting this way, the way I did, is much easier just doing it this way. But if you're going to sort on this variable and then on this variable, so like a multi-level sort, you can't do that in here. You have to use a sort tool. And we're going to have to do a multi-level sort here in just a second. Right here, question 7. For each of our top 3 most profitable customers, what are our top 3 most profitable products? So what we can do is we can first, what was our first question? Is it our top 3 most profitable customers? So we had done this summarize tool, we had grouped by customer ID, then we had summed the profit. Now the question is, for each of our top 3 most profitable customers, what are our top 3 most profitable products? So we can group by customer ID, then group by product name, then group by profit, and then hit run. The output of that looks like this. So for each customer, here are the products we sold to that customer. Here's the profit we made on each of those products. But we haven't sorted. So within this customer 1, we need to sort these products by profit. So coffee would be at the top. Then it looks like clam chowder. And then crab meat. And then customer 3, we sold them 3 different products. And if we sort those by profit, it would be chowder, then syrup, then curry sauce. So how to take this and then further sort it? We could use a sort tool. And we're going to sort customer ID in ascending order, and then by profit in descending order. Run. For each customer, we've sorted the products by their profit. You can see that here. You should be able to see that. Customer 6, here are the products we sold. Most profitable is beer, then apples, then pears. It's all sorted. Within the customer ID, we've sorted by profit. So this is a multi-level sort here. But the question was for each of our top 3 most profitable customers. What are our top 3 most profitable products? We need to figure out, well, which of these was our top 3 most profitable customers. And so to do that, remember that's whenever we were just taking our original summarized tool and we had just grouped by customer ID and summed the profit. But I've already changed this. So let's just attach another one here. Oops, not there. I did not mean to do that. Delete. Let's pull another one. Just so I can remember who are our top 3 most profitable customers. I want to pull this over here. Just redo what I did earlier. For question 1, group by customer ID, sum the profit. Get the results. Then sort this in descending order. So our top 3 most profitable customers were 28, 7, and 4. So when we go look at this data here, 28, 7, and 4. So 28. What are our top 3 most profitable products for 28? Coffee first, then crab meat, then clam chowder. We only sold 3 products to customer 28. 28 was our most profitable customer. And then 7 was our second most profitable customer. For customer 7, we only sold 1 product to them. So we don't really need, that was the most profitable one. And then customer 4 was our third most profitable company. And customer 4, we sold all these products. The top 3 in terms of profitability were boysenberry spread, dried apples, and noshi. So for each of our top 3 most profitable customers, 28, 7, and 4, what are our top 3 most profitable products? For 28, it was coffee, crab meat, clam chowder. For 7, we only sold them 1 product, so that had to be the most profitable by default. It was coffee. And for customer 4, our third most profitable customer, the top 3 profitable products we sold to them were first boysenberry spread, then dried apples, then noshi. So this question is very simple on the surface, but actually to get the answer, you have to do some multi-level sorting. Question 8. For which customers do we take the longest to fulfill orders? Well, let's see. If we go back to our original database, remember, some of these orders were multi-product orders. And we're going to run into that same problem if we go and we're trying to find the average order fulfillment time by customer. Now, this is all one customer right here, but it's only 1 order. It's not 3 orders. So we only need 1. We only need the 9 once. So we need to find the unique orders, which we did that here. And then to the unique orders, we need to attach summarize tool. No. need to attach. I'm just going to put the summarize tool out here. If you put it too close, it tries to link to one. I don't want it to link to that. I want it to link to this. And we're trying to find, what was the question again? For which customers do we take the longest to fulfill orders? I'm going to take this and group by, I had a bug on my screen. I'm going to group by customer ID, because now we're just looking at the unique orders. Group by customer ID, and then the variable we care about is order fulfillment time, and we want the average. For each customer, that gives us the average order fulfillment time. Here they are. Then we can sort this by average order fulfillment time in descending order, and we can figure out the customers that we take the longest to fulfill orders. Customer 7, customer 27, and customer 1. These are the 3 customers that we take the longest to fulfill orders. For which products do we take the longest to fulfill orders? Here, we can attach our summarize tool, or we need to attach our summarize tool directly to our database, because each row of this database is a different product, right? It might be the same order, like this is all the same order, but they're different products. And so if we just attach a summarize tool to this database, and we group by product name, they're going to get different product names, and then find the average order fulfillment time in days. That'll be correct. We don't have to worry about the unique ones. Hopefully you realize that, you see that. So we're going to group by product name or product code. Product name is more descriptive. And we're going to find the average order fulfillment time. And this might be a little misleading though. And here's why. I'll show you. So here are our products, and here's the average order fulfillment time. If one of these products happens to be a product that the company usually orders with another product, so it's part of a multi-product order, then the average fulfillment time listed beside that product it's not necessarily how long it takes to make that product, because that's a multi-product order. It's how long it takes to fulfill that multi-product order is what it is. And so you could be misled and think that certain products are taking more time to fulfill, but if they're part of, like if this boysenberry spread product is usually a part of a 3-product order, there's also 2 other products they order, then the average order fulfillment time listed beside boysenberry spread will be higher. It's because the company has to make the other 2 products as well, because they're shipping 3 products. It takes longer. It's not because of just this product though. So this might be misleading, but anyway, sort this in descending order. On average, orders containing Cajun seasoning as a product take 8 days to fulfill. That's probably the best way to state it. Orders containing dried apples as a product take 7 days to fulfill, and orders containing dried pears as a product take 7 days to fulfill. So these and Noshi as well. So our top 3 in terms of order fulfillment time, really there's 4, because these are tied here. These all 3 are tied. Cajun seasoning, dried apples, dried pears, and Noshi. These tend to take longer to ship to the customers for whatever reason, or to fulfill the order. And then finally, how many unique customers placed an order for more than one product? All right, go back to our database. We have our order IDs. Some order IDs are multi-product orders. We want to know how many unique customers placed a multi-product order, an order for more than one product. So we filtered our database. We used the unique tool, and we found the unique order IDs. And that was here. It spit out the unique order IDs, but then it also spit out the duplicate order IDs. What's a duplicate order ID? It's a multi-product order. Because when you have a multi-product order in our original database, you have that order ID will show up more than once for each product in that order. And so the duplicate order IDs are the multi-product orders. So here are all the multi-product orders. And then in this, we need to find the unique customer IDs. These are all the customers that placed an order for more than one product. So we attach another unique tool. Where's unique? I'm going to put it out over here to the duplicate portion of our order IDs. And then this one, we're going to find the unique customer IDs. Twelve customers placed a multi-product order. Customer 1, 3, 4, 6, 8, 9, 10, 11, 12, 26, 27, and 28 all placed multi-product orders. So 12 is the answer to that question. All right, that concludes this video, and that wraps up what I wanted to do on this case. Introduction to databases for accountants using Alteryx. Hopefully you see the importance of using Alteryx to merge various data sets together to create a database, and then from the database, query the database to answer key questions, important questions that companies would want to answer.